I've known Jeff and Corinna for a while, and they're both practitioners. They're builders, building scientific superintelligence. And so instead of being at the theoretical, like what could it be, I wanted you to hear from builders. Jeff was a Lemelson Prize winner. That's like the highest honor at MIT for invention, a mentee of Sangeeta Bhatia, and he went to Flagship and built a ton of companies. I think 10 billion, what's the number, 10 billion or something?
Close to that.
Yeah, just you say it so I don't say it wrong.
I actually don't know what the current number is.
Yeah, because the stock market's going like this. But he's built a lot of companies out of Flagship. And then he said, you know what, I'm going to build a company, instead of handing it off, kind of like handing off Moderna or something, he said, I'm going to keep this one, and I'm going to go the distance. And I'm really proud of what he's doing, and it relates to the topic of scientific superintelligence. Corinna, Rhodes Scholar. If you know your Rhodes Scholarship, I think it's like 32 Rhodes a year, and it's regional. She represents China, so to me that's interesting. You can't talk about AI without thinking about all the global players. She's, in addition to being an MIT grad, she also is at Stanford now, getting a math PhD, and in the Stanford Law School. She's a Hennessy Scholar, but I think she's dropping out, and it's not because the work is too hard. It's not because she is bored. It's because she has a startup, because she thinks this is a moment around scientific superintelligence. So you have two builders, and then Ricardo is one of the most thoughtful people. Technically, like what
quantum physicist.
You're what?
Quantum physicist. Theoretical physicist.
Yeah. So he's here to help me kind of ask some questions here and help enlighten you all. All right, so scientific superintelligence. Jeff, please define that. What does that term mean to you? What does it mean to you today? Why are you dedicating this moment? You could be doing anything in 2025, which is such an interesting time in AI. Why is this important? Why do you think everyone should care about this?
First of all, thanks for having me. It's a beautiful topic, and I love the discussion so far. It's easy to make a case that intelligence going up in science, if it is nigh, is the most important thing in the world today, and probably the most important thing in the history of science. A simple point of context for that argument would be that 100% of the science and technology in our civilization and our lives sits on a foundation of human-level intelligence. Nothing in this room was invented by chimpanzees. The IQ of a chimpanzee is about 25. Humans are 100-ish, and we have no idea what the ceiling of intelligence here forward will be. If it's even close to a delta like 75, then human-level intelligence will be the foundation for something like 0% of future technologies, and all of that accruing to wherever the upper bound goes. So our mission is to achieve scientific superintelligence, and we also believe this is the most inspiring frontier, in that, as just described, one of the concerns about AI's mastery of existing human professions is that a direct consequence may be the elimination of tens of millions or hundreds of millions of jobs. Science is different in that the purpose of science isn't just to practice a rendition of an existing profession or the past. It's to try to reach into the future and grab solutions to problems that we don't have access to today. And you could think about scientific intelligence being kind of like a form of drill bit with which to extract things that are a second away, a decade away, or further. So unless the future has a desert of new technologies, then increasing scientific intelligence is going to be sort of the ultimate mission to try to bring a better future into the present.
So comment on AlphaFold and vibe coding. What does that have to do with what you're doing? And then tell us what Lila is.
Yeah, so AlphaFold is, could be described in many ways. It was the use of machine learning to determine how these amazing machines, motors, sensors, and devices that we call proteins go from a noodle, a string of amino acids being spit out of a ribosome, into a shape and functional device. And physics and all of our first principles plus human brains had not performed very well in trying to solve that challenge. And AI has done marvelously. You could think of AlphaFold as a very narrow but really scientifically important form of superintelligence for that reason. And what we came to conclude 6-7 years ago in working on generative AI applied to antibody design and peptide design and a bunch of other areas was that such narrow forms of superintelligence were going to become more and more prevalent in science, and eventually something which is able to broadly surpass human intelligence on every step of the wheel that we call science, meaning the ability to call upon tools to model the way that the world works, to propose a brilliant hypothesis, to autonomously design a decisive experiment to test that hypothesis in the real world. And then we're building a combination of robotics, instrumentation, and automation through which such experiments can be run autonomously. And then the result can be interpreted at 3 o'clock in the morning, and the model from which the hypothesis came from can set the next rotation in motion. So yeah, I haven't made an analogy before between vibe coding and what we're doing, but if we're right, science is about to get...
outsourcing, you know, where other time zones people would work when you were sleeping, and you'd wake up. You know, I met the guy, Kanodia, who did the first outsourcing in India. But vibe coding and outsourcing, it has some relationship here.
Yeah, I mean, imagine vibe science, where the drudgery, the monotony, the things that, you know, keep the rate of brilliant idea being ground truths to once a year if you're lucky, once a lifetime sometimes, to being this ever faster video game, where one can set ideas in motion within your domain of expertise, one can reach beyond you know, the specialization with which one was trained and contribute across many fields, you know, with the help of a combination of a higher intelligence to dissolve some of our disciplinary boundaries and to elevate the imagination and creativity that we can pour into science.
So I want to go to Krina, but first, can you just say, what is Lila? I said you're a builder. You know, how many employees, have you raised money, and what are you trying to do with it?
So Lila's mission is scientific superintelligence.
And is it stealth? Can we tell people about it?
It no longer is stealth.
Okay.
We had a reporter spend 3 days with us a few months ago. You never quite know what you're getting into.
Yeah.
But it resulted in a nice New York Times piece on Lila and its mission. And we're building a combination of what we call autonomous science systems. And our belief is that whomever is the winner of autonomous science will gain an enduring lead in their scientific intelligence. Internet-level scientific intelligence will go up to some ceiling. It's also going to be very rapidly democratized. And we believe whomever can build the equivalent of the world's largest verifier for scientific reasoning models, which we believe needs to be a lab, is going to have the highest scientific intelligence. So we've raised a SAFE round last year. Some of you may be familiar. It's an acronym, Simple Agreement for Future Equity. It's a seed financing. It was large. It's a $200 million round. And
have you raised 200?
Not 200,
Yeah,
but
okay.
around.
Yeah, okay. Yeah.
yeah, we've been making some really beautiful progress.
Yeah, and how many people? Or
About 100 people today.
100 people. Are you hiring?
We're aggressively hiring, yeah.
Aggressively hiring, not just hiring. Okay, aggressively hiring. How are you hiring? Aggressively. All right. All right, Krina, what are you doing in the space? I know you're taking on math and quant. Please tell us, you know, why you're dropping out of Stanford to do this. You still have your MIT degree.
That's right. So at Axiom, we are having a moonshot mission of quantitative superintelligence. Think about all the kind of math education you had in high school. There's this kind of problems that just ask for one numerical answer, and there's another kind of problem that asks you to show your work, to give step-by-step proofs. Frontier large language models, despite all the amazing post-training breakthroughs, are still pretty bad at doing proofs. They will give you a numerical answer. In fact, they can do it really well. On the American Invitational Math Examination, frontier large language models achieve a 96% score. However, when you ask it to show its proof, the score drops to 5%. So why a huge difference? It's because the way we train them. It's doing a lot of pattern matching with its existing training data. It's doing a lot of retrieval, but it's not doing actual reasoning. What we want to build at Axiom is to use programming language to train the machine to be able to speak the language of formal proofs. with this sort of formal signals injected and propagated into the reasoning, we believe that we can not only solve the hardest problems that perplex research mathematicians, but to generate consistently correct intermediate steps that tell you you can trust the result and you can use it in high-stake, low-error rate tolerant cases. We envision a future where AI mathematicians are deployed into all the industry sectors that currently do not use a lot of mathematicians, because we live in a math-poor world. Axiom's mission is to increase the supply of mathematical superintelligence, to make the world math-rich, and to enable vibe proving. That means anyone can leverage their quantitative intuitions using formal language and the help of machine learning to then realize your mathematical plan for the system you are trying to understand, for the time series data you are trying to predict, for the cryptographic verification you are trying to do securely. We want to enable that world where everyone can achieve their version of quantitative superintelligence.
So Corinna talked about math and quant. I know you have a life science background, but material science, like what are the domains you're trying to address, or is it infinite? And then Ricardo, love to have you take these folks on and see what's on their mind.
Well, one of the things that we realized a couple of years ago in applying autonomous science and building systems for material science, chemistry, and life, which we thought would be very different, was that those are largely different because we grow up believing they're different.
Yeah.
But they all practice the same scientific method. And when you generalize the difficult problems you have to solve to make any subset of science run autonomously, at the level of the intellectual or the physical steps, the general statement of those, if solved, gives you almost the rest of science for free. So under one roof, we've got a combination of life scientists, material scientists, and chemists trying to dissolve some of the boundaries that we've imposed on science because of our own limitations.
Like nano, 10 to the 9th. We're not small enough to hang out at that level. Are you going to help contribute to that?
Yeah, neither
10 to
our
the negative
bodies
not
nor
10 to the
our...
9th, that would be big.
Neither our bodies nor our brains are really optimally suited for science.
Yeah.
Particularly in learning about how the world works from the atoms up. We can make the same case for math. Try as our brains have. While it's tempting to imagine that our intelligence is a ceiling, when you're immersed in these fields, it's very easy to imagine that it is that it is not.
All right, Ricardo, he's very well versed in this.
I'm going to give a 30-second of where I come from, and then we brainstorm. So I'm a theoretical physicist, but right now I'm a drug developer. So in Organics Biosciences, we develop drugs, and we designed the company since a decade to be ready on this forefront of numerical innovation. So when you enter in a biotech company or in a sophisticated bleeding-edge pharma company, what you see is a sci-fi movie already. So you have full robotic automation displaced, you have large numerical efforts constantly running. Today, one of our footprints, we run 150 million molecular experiments fully unmanned. There is no human running those experiments with full robotic automation. Generate terabytes of data, and we have a sweep of numerical models that are fighting the various computational challenges in between. Now, what I really like of John's point and we were discussing yesterday is one of the things that we quickly started to integrate, and I see a transition moment between now and superintelligence, is this vibe intelligence. And I love the coder word, they picked this word. When you look at a coder today, instead of going and searching in Stack Overflow every 3 seconds and having to copy and paste from his own old code, you have open on the right side of your screen an LLM. This is going to do boilerplating for you. It's going to do like 80% of the boring coding that has been done in the past, and you don't want to reinvent like a pub sub queue, so you're asking it, and it gets in. And in this way, LLMs are somehow probabilistic databases. So you can access the history of where they've been trained, and you can stretch the Gaussian a little bit to kind of innovate over the center of the Gaussian. And that's, I think, is going to impact profoundly how we're going to do research, especially when we can tap in proprietary data. The challenge that I want to brainstorm here is that these Gaussians, so these probabilistic databases, have a strange behavior, and they are kind of in love of the averages. If today you open your mobile phone and you ask one of the modern image producer if you can draw an analog watch set at 2:25 p.m., you will have a plethora of analog watches, but none of them will show 2:25 p.m. They will always show 10:10. The reason is that the majority, if not the complete set of pictures of watches in the entire world, points at 10:10 for pleasant vision of the user that likes to see these clocks. So the LLMs learn that watches, they must really obsess of 10:10. And so any watch in the world has to be a 10:10 stuck there. And you can go around the distance, so you can have a pretty analog watch. You can have a clumsy analog watch, but you can't have a 2:25 analog watch. And it's bizarre if you think about it. Like such a simple concept learning thing. So what I want to just brainstorm with you guys, how many breakthroughs you think, or is LLM really leading us towards superintelligence? Or do we have to augment and break this Gaussian chain that we are living into and start to have this ontological representation of science to really break through the ceiling? And how long, I mean, forecasting timelines is always a tragedy, so I'm not going to ask that. But what do you think are the main blocks that you, or is LLM instead going to take us straight to superintelligence?
Do you want to go first?
Yeah, sure. So from my kind of domain, the quantitative superintelligence part, what we have seen that is problematic is this sort of keep generating reasoning traces and then train on those reasoning traces. But if your reasoning traces are already having hallucination at scale, then it's very hard to kind of break the pattern. Mm-hmm. What we have seen is there's two kinds of intuitions. One kind of intuition is that for the kind of outlier distribution, like you say, on the Gaussian curve, those are usually the aha moments. Those kind of aha moments are currently coming from expert data in solving really hard math questions. But those kind of aha moments are not factored out of the chain of reasoning. Mm-hmm. So that when it's doing kind of pattern matching, it's very hard to capture and reuse those aha moments. Instead, it might kind of misapply it to different scenarios, causing the sort of hallucination. What we want to build is to kind of factor the proof into different states, where we can then reliably retrieve the relevant aha moments and to discard the ones that are not actually helpful.
Clear.
Using that technique, we are able to kind of push to the kind of outlier part of the Gaussian distribution that's correct. Yep. Because at the outlier part, you usually have either just totally irrelevant stuff or the real gold.
Yeah, exactly. The breakthroughs.
Yeah.
I love this question. I'll pull it to Juan's talk earlier in that none of us should feel like any aspect of our intelligent contributions to the world are safe. But none of us really knows in what order the sea level of intelligence will rise and subsume imagination or subsume, extreme, novel logical derivation. But there's probably a rough boundary where if one is searching for information within the repository of what is known, then that is underwater now or will be underwater virtually immediately. Yeah. And professions that do that, which is a lot of the global workforce, are particularly in danger. But as probably everybody here knows, the essence of LLMs is that they are predicting the most probable next token. And so at the limit, what that means is that they're built to recapitulate dogma or consensus. And in science, that has a very limited regime of utility in that, try as we have, the human brain understands a really, really small fraction of how the world works. And in fact, to understand it, we've been dividing it into sub specialties. So I believe something like imagination and like taste for novelty is going to hang around as a human contribution for a while. Mm-hmm. And it's part of the reason I believe science is going to get way more fun. If you just take the Edisonian 1% inspiration, 99% perspiration, if we can put the 99% perspiration into a new paradigm, then we have 100x improvement in something like the quality of life for scientists, and and likely the quantity of output. There's also going to be all these places where, as LLMs are, if you've had that experience where you say something out loud and you realize by saying it that you're questioning its validity. Like, oh, the human body has 3 trillion cells. Wait, does it? Mm-hmm. Like, who actually determined that? And, it might be that the right type of reasoning models are going to find all these beautiful imperfections. There's just a little bit of evidence if we can search cogently in the lower probability scenarios that will reveal aha moments and epiphanies, within the many folds of the way we've been describing the world so far.
Apologies.
What we have seen, for example, building on the point, is in structured data, you can try to model some sort of novelty, taste, beauty, elegance, usefulness of the various sort of theorems, results, scientific discoveries. What we have seen is that, for example, you can have a model try to kind of give scores to how something is, useful, as in adding that knowledge to your existing knowledge base. How much more nodes do you create? That is a metric that can be quantified. You can also kind of measure novelty by, suppose this result, relies on both number theory and probability, bridging 2, distant fields in the past. You can look at the dependency graph of that problem and call it novel. So we have kind of seen some attempts in having machines to kind of imitate the sort of taste of what is good, what is strange, what is exotic for those kind of scientific results, which I think have so much potential in both kind of the quantitative domains and the life sciences space and physical intelligence space that other folks in the ecosystem are working towards.
So I see we have Secretary of Economic Development Yvonne Howe and Deputy Secretary of Economic Development Ashley Stroba in the audience. I said the two of you are builders. How is this going to help build the economy? Pythagorean is probably saying, if only I had this tool back then. But I'm just wondering, what does this mean for people in the Commonwealth? What does this mean for people in the United States and China and the world in terms of achieving business outcomes? I mean, you're a Lemelson Prize winner, you're a Rhodes Scholar. I do wonder if LLMs, or if superintelligence, what does that mean? Is that a leveling field? Do we create more things? Is a Rhodes Scholarship going to get is a superintelligent going to get a Rhodes Scholarship? What is next?
Well, if you squint a little bit, at the sort of GDP of civilization, all of it is sitting on a foundation of an increasingly extraordinary science and technological base. So unless that changes, then logically the most valuable thing we can do is to increase intelligence in science. There are a bunch of efficiency gains that will come along the way. But I think the revolution that I referenced at the beginning is the pertinent one. Like, we've had a lot of technology revolutions throughout human history. We have not had an intelligence revolution. That took place with the emergence of humans from the rest of the animal kingdom. So it is really difficult to
Neanderthal,
estimate, what's ahead as intelligence goes up. Like, the number of things that the rest of the animal kingdom doesn't understand about the world that we do is probably a predictor of the number of things that future AI models will understand about the world that we don't. And
so, like
science,
new materials, climate, like what are the industries that you want to take on?
Yeah, I'll start with
right now, lithium is in Bolivia, and that creates some international stuff. Oil in the Middle East, that creates some things in the 70s. Can superintelligence address?
Yeah, in the reality in life science, in chemistry, materials, and more, is that our brains really struggle to understand what is going on below the sort of diffusion limit of being able to observe things with a microscope. But machines are much better at matching those patterns, like you described AlphaFold. And as AI begins to learn how atoms in the world connect to the arrays of functions that manifest across these fields with greater and greater brilliance, the implications for every single technology domain that we're familiar with are are really, really amazing.
So maybe follow up just, and Corinna add to this, like who are the customers of your product and how do they benefit from it that you're creating?
Yeah. So we have seen mathematical intelligence being channeled in various industry sectors, such as quant finance. So Jim Simons had this idea that if you just do math and not think about the kind of macroeconomics, just look at the financial data, do it the mathematical way, you can generate huge amount of market returns. That's, I think, a very telling example of the commercial value of mathematics. If you think about history, abacus leads to accounting, trade and commerce. Integrals, calculus, leads to mechanics, thermodynamics, industrial revolution. The invention of Babbage machine, that is this sort of tool, weird tool to calculate logarithms faster, that was a prototype of computer. And here we are, the artificial general intelligence era. So the kind of creation of math tools always lead to new use cases, market sectors, and also rely on call for more math tools and more mathematical reasoning power. So we want to kind of channel this sort of mathematical intelligence into the market sectors, such as quant finance, defense, cryptographic verification, engineering and simulations, and so on.
So be specific, who's the customer for Lila?
Customers that are interested in better performing technologies across therapeutics, agricultural technologies, industrial chemistries, and new materials that can do what you described, which is substitute for a rare earth component that we rely upon technologically today, or perform provide higher performance and lower cost across some of the biggest energy challenges that we have.
Great.
All of those are based on how atoms in the world connect to functional outcomes.
Great. Closing question.
Closing question. Tough one. So how much, well, again, I'm a numerical guy, so I spend my life in building simulations of reality. And there are a lot of you guys in the room that wrote these codes. I see mathematics as a complete language, so it's a fantastic sweet spot to land, and I'm very excited for your work. The science, there is this representation of digital science, so lots of simulation codes and so on and so forth. What you see is the first low-hanging fruit. Are the superintelligence going to work in a fully in silico way, so they're going to plan and test reality in a simulation, or you see reach out in the physical, so they're going to plan and test the reality in the lab, in a physical space? What and how much you think is going to be the balance in the long term?
Where we've been starting is allowing real-world verification to be done autonomously.
Yeah.
Based on the perspective that AI models are going to increasingly liberate avalanches of interesting ideas as to how the world works and how it could work. And within that domain, because it's calling upon generative models that can three-dimensionally model the world more accurately than our brains can, even early versions of the system have dramatically accelerated the ability to find new materials, for example, electrodes for green hydrogen production, as well as to design protein therapeutics, mRNA therapeutics, and seemingly really disparate endeavors across life.
Very cool.
Real quick, did you answer?
Yeah, in math, we see grading being a much simpler task. We have automated theorem-proving checkers. We also have LLMs as judges to kind of determine the quality of the data sources. So verification is relatively easier here.
Okay, scientific superintelligence, you heard it here. And you're aggressively hiring?
Aggressively hiring.
Are you moderately, how are you?
We're aggressively hiring as well.
Okay.
So if you're interested
Who wants
in
to
math.
work with these two wonderful people? All right, so yeah, no, you have a job. I thought Yvonne raised her hand. All right, so thank you.
Thank you.
All right.